Going live. All right. Welcome, everyone, to your Thursday night dose of astronomy. So glad that you could join us here this evening. I'm Irene Pease. I'm with the Amateur Astronomers Association of New York, and I will be taking you on a little tour around your local universe, like I do. So, just getting things started off, again, two of the programs that I'll be using are OpenSpace. You can see more about OpenSpace and you can download it for free. It's freeware. You can download that at openspaceproject.com. So, that's what you're seeing in the background now. We'll come back to this, but we'll first be using Stellarium. And you can download that and read all about that at stellarium.org. That you can put on your devices, laptops, computers, whatever. So, yeah, so let's go ahead and jump on over to our Stellarium view of things. So, Stellarium, looking at the sky. And there's something happening here, which is it's really bright out. So, as usual, should be starting it now. Nope, it's almost now. So I meant to click this to now. So in Brooklyn, it's, yeah, pushing 8 o'clock after 8, and it's still really light out. So what's up with that? Well, we're about a week away from the summer solstice, so it's going to get it's going to stay bright pretty late, and next week's going to be even later, but that's okay. We'll survive. So we'll go ahead and fast forward 2 hours to about 10 o'clock. And as usual, I just want to kind of see what's up in the night sky. There's some summery constellations I want to point out. It's not quite summer yet astronomically, but we're pretty close. So we'll go ahead and take a look at some summer things in our night sky. So some of this might be a review, but that's okay because, the sky is review. Like every year, it's the same thing, more or less. But there's always new, cool, deeper, darker, fun things to see and to look for. So we're going to start up overhead. It's technically in the north. We spin around and look north. We'll look west. So this is kind of in the west-ish part of the sky, but basically very high overhead. A lot of you might recognize the Big Dipper. So that's 7 stars we have 3 stars in the handle and 4 stars in the cup, and those are part of the constellation Ursa Major, which is actually pretty huge, but that's the full constellation for you. But the Big Dipper, fairly bright, definitely bright enough to see from Brooklyn and other bright cities. And we can use that to find some other things. So I think a few weeks ago, we've done the whole Arcturus thing. So we're going to do a little bit more along that stream right now. So if you follow the arc of the handle, arcing to Arcturus, you come to this bright star. It's a slightly yellowish star. If you see in the sky, you might notice a little bit of color in there. And that is in the constellation Boötes. So Boötes, or some people call it booties. There's actually like a umlaut over the second O. So that's supposed to be, I don't know, what do you see there? So I'm not going to tell you what it's supposed to be. I'm going to tell you what I see, and you can look up what it's supposed to be in Wikipedia, whatever. So I know it's not quite technically summer, but I think the heat is getting to be kind of a bit much. And so we're going to focus on cooling off, getting away from the heat, and looking at some cooler things this week. So that's kind of where Boötes first comes in. So I see Boötes as like a giant ice cream cone in the sky. So Arcturus is and this, like, it almost looks like the ice cream cone has legs, like it's gonna run away. Don't let your ice cream cone run away. So we have kind of like this triangle, that's the cone, and then these stars connect up to make a big blob of ice cream on top. And I even made a neat little image of that. I was trying to be fancy about this, which is I was a few minutes late, but here's my fancy image and to help you visualize the ice cream cone. So they're arcing to Arcturus, and this is your ice cream cone. So the cone and the blob of ice cream. And yes, this is flavored. I'm calling it cosmic cherry chip. So cosmic cherry chip is the flavor of this year. That's all the rage. And then also I drew this red thing. Bonus points for anyone who can figure out what that's supposed to be before I tell you. Hint, it's aimed at the ice cream cone. So, yeah. So that is this little constellation here. This is called Corona Borealis. So we have Bootes, the ice cream cone, and then Corona Borealis is, yeah, it's a giant tongue that's going to lick that ice cream cone because, just having a giant ice cream cone in the sky would be such a waste if there was no one there to eat it. So Bootes, the ice cream cone, Corona Borealis is a little bit fainter. There's the one brighter star, Alpha Corona Borealis, that's going to be spottable from parks. I've seen it from Prospect Park in Brooklyn. The other stars that make up kind of that curve of the tongue, those are a little bit trickier, but definitely that bright one. And if you're in a darker site, you can probably see all of those and make like a curve. So someone eating ice cream up in the sky. What a nice thought. So that's your challenge for this week is to try and find an ice cream cone in the sky and the giant tongue. And bonus points if you actually are eating an ice cream cone while looking at it. Because, yeah, it's almost summertime. So that's all I wanted to do in Stellarium for this week. We'll go ahead and start looking at more of these constellations around here. So week by week, we'll kind of add on, maybe review some that we've seen in the past. But those will be overhead. And again, it's so late. So if you're still working in the mornings, it's kind of late to be staying up past 10 to look for these constellations in the night sky. But if you do, that's great. So we'll pop on over then to OpenSpace. So we'll go ahead and close out Stellarium for now and make sure, yep, my OpenSpace is on. There, that looks like OpenSpace. And yeah, so we're starting here on Earth for perspective. And let's go ahead and turn off the orbits of the planets there. And kind of start to move away a little bit. So I said I wanted to talk about some cooler things. So yeah, we're going to stay local. We're going to stay in the solar system. So not in the Earth-Moon system, but we will stay in the solar system for today. And where are the coolest places in the solar system? So there's a couple cool places. I mean, if you've been to Antarctica, yeah, that's nice. But there are cooler places off-world. Maybe just leave these on for reference. So, and again, just as a quick intro to OpenSpace, again, this is freeware, downloadable from openspaceproject.com. And so it's a program that you can use to basically fly around the universe in 3 dimensions, like we're doing this evening, just sticking to the solar system for tonight, but it goes much beyond the solar system. And all the stars and everything you see in the background, some of the images of worlds that we'll look at in addition to the Earth here, all of that is based on real data. So we have the Digital Universe Atlas. It's mostly curated at the Museum of Natural History in New York. And there are other data sets that come from other missions, from NASA, from the European Space Agency, and others. So all real data as much as possible. So we'll just focus on the sun momentarily and kind of looking down on all the planets. Actually pull out so we can see all the planet orbits. We have the inner planets there, Mercury, Venus, Earth, Mars, and then way out here, Jupiter, Saturn, Uranus, Neptune. Yes, all 8 planets. So the inner ones are really in there. Outer ones are, out there. But yeah, so as far as cold worlds, actually the coldest planet where we find the lowest temperatures for any planet, these are planets, right, of the 8, would be, you guessed it, Mercury. So because Mercury spins so slowly and because it has no atmosphere, we actually have really high and really low temperatures on Mercury. So we'll just take a quick pit stop by Mercury before we head further out where all the other cool stuff is. So Mercury being closest to the sun, you'd think, oh yeah, hot, because it's, close to the sun, which is, kind of known for being hot. Um, but again, it's rotating very, very slowly. So on the day side of Mercury, the sun facing side, it gets, yes, really stinking hot. It's the second hottest planet because Venus has that greenhouse effect going for it. So Venus is actually going to be even hotter than the hottest parts of Mercury. But on the night side, it cools off a lot because it's just exposed to the vacuum of space, which, so all that heat from the daylight, from the daytime, radiates away and it gets very, very cold. Our moon it looks similar to Mercury. It's further away. So you think, well, why doesn't the moon get colder? Well, the moon doesn't get to cool off as much. The moon is being exposed to sunlight further away, but it's exposed to sunlight every month. So it, um, gets that exposure. But there are parts of Mercury on the night side that are going to be in night, so they're going to be not exposed to sunlight. They'll be radiating away their heat for much longer than a month. So Mercury, its orbit and rotation are kind of odd, and maybe I'll do a whole thing about that sometime, but not today. So yeah, so Mercury is actually the coldest planet. That's a little fun fact. You're welcome. And and then the other cold stuff is going to be more where you'd expect it to be further out in the solar system. So let's go ahead and, yeah, move further out and see some of those colder bits. Um, there are some cold bits of ice out in the asteroids that are between Mars and Jupiter, and we have travelers from the far outer solar system that I just wanted to call out. We actually get, let me just turn on a couple of asteroids actually. Um, so yeah. So the asteroids further out, but the the things that get much colder because they're smaller bodies, but they travel from the far outer solar system beyond the planets. Actually, we get comets that come in from way past the outer orbits of the planets. They heat up, get warmer when they turn around the sun, and then fly back out further. The asteroids have more stable orbits, but we do have visitors from the far outer solar system, some very small solar system bodies. So we can kind of get an idea of what it's like further out there, but not so far out. So we have visitors, ices from the comets. Actually, that's what's going to give them those tails. So I am going to talk about ices on these other solar system bodies. So you might be familiar again with seeing ices coming off of comets. They may or may not be water ice. So when we say ices, we're referring to possibly water ice. It could be methane, it could be ammonia, carbon dioxide, carbon monoxide. All of those gases can condense if cold enough, condense into like really tiny grain-sized particles, and form little bits in there. So those are some of the ices that we talk about. When we talk about ices in the solar system, don't just think water ice. Yeah, that's part of it, but you're also going to have methane, ammonium, carbon dioxide, carbon monoxide. So the next world that I want to visit, not super far out, but a little ways out. Pull back in here so we can try and guess what we're looking at next. It'll be like a surprise when we get there. I think this is one we've visited before, but it has, well, a lot of ice. So a way to cool off. So we're looking at something orbiting Saturn. And as we come in here, ooh, it's a ball. Yep, no, there's actually a real skin on there. So we do have maps of this world. So it has had a few satellites fly by it. This is Enceladus. So Enceladus is one of the larger moons of Saturn. And actually I want to show kind of a neat effect that we're just going to take a detour from ices momentarily and show kind of a neat effect. So you can see Saturn in the background. So isn't that a lovely view? So if you were on Enceladus, you'd have like this giant Saturn in your sky, but only if you're on the certain side of Enceladus. So if we move through time, right? So we're kind of speeding up through time, we can see only one side of Enceladus gets to face Saturn. So most of the large moons in the solar system, our moon included, Jupiter's Galilean moons and Saturn's largest moons and Neptune's large moon, they're all what we call tidally locked, meaning that the same side of the moon is always facing the planet. So if you're on Saturn, you'd only see one side of Enceladus. So that's kind of interesting. So we do have images of all sides of Enceladus because we didn't just take image of it. We didn't like land on Saturn. We've never done that. So we have images of, all the parts of Enceladus. But yeah, so tidal locking, totally different, but kind of interesting to think about there. So we'll turn down the time and just kind of look at some of the markings on Enceladus. So I said it's got mostly ice on its surface, so a lot of water ice. It is highly reflective, which if it's reflecting heat, if it's reflecting light, so it's reflecting heat, which means it's not absorbing it, which means it's even colder than it would be if it were absorbing more. And then down, especially towards its south pole, we have all these like cracks and scratches. Some people call it like, so there's certain sets that we call tiger stripes because they're almost like, well, I guess stripes on a tiger. That's just how astronomers name things. Make it pretty obvious. But our first kind of hint of the excitement of Enceladus was back in 1980, 81, when Voyager 2 went zipping past it and took a couple of snapshots and caught what we thought might be interesting. And so when the Cassini mission went and visited the Saturnian system back in the early 2000s, it did some really close passes to Enceladus. 2005, we've got, that's where we have these maps from. So Voyager 1 didn't send us these gorgeous detailed maps of Enceladus' surface. These are from the Cassini mission, the European Space Agency that sent the Cassini-Huygens mission. Huygens was the probe that went down and landed on Titan and did all kinds of cool stuff there. But yeah, so we have the maps of several of Saturn's moons actually from Cassini. But yeah, just looking at these stripes on here, we think that there's basically a liquid ocean, like a liquid mantle that was maybe water, maybe very salty water. And so that could be driving, as it's moving, it could be driving solid ice chunks on the surface. So think kind of like Earth's plate tectonics. So we have these lithospheric plates that you learned about in like 8th grade earth science or whatever, and those are kind of floating on this it's not so much liquid, it's more plastic, the geologists tell me. It's more like plastic mantle. And so we can imagine something similar happening here, but with very different viscosity, right? So the water can flow probably a lot more easily than Earth's plastic mantle. So you get like probably cracks in the ice and scratches and marks from that, we think. The other neato thing that Cassini took a picture of, I just want to share real quick. So yeah, you can see the credit here. This is NASA JPL Space Science Institute. These are jets of ices, volatiles being ejected out into space. So from the surface of Cassini, and probably not just individual holes, but probably more like streaks. So almost along here, you can almost see like a line. So there's like a sheet of material being ejected into space. So this is a very exciting thing that we call cryovolcanism. So we have volcanism all over the Earth, mainly along those plate boundaries, or lithospheric plate boundaries, where you have seismicity, you have volcanism, you have volcanoes and quakes and yeah, all kinds of terrifying things. but they're good for the carbon cycle, so we kind of need that as part of our life cycle, even though it's, immediately hazardous to anyone around it. But here we, instead of having like hot things, we have these cold ices jetting out of there. So this is one of the few places in the solar system that cryovolcanism is taking place. So hopefully, future missions will send back more information about that um, from Enceladus, possibly other worlds that may have cryovolcanism, such as Titan, maybe Ceres. And in the comments, I see a request for Pluto, and yes, that is our next planned stop. I mean, no, I'm doing that because you asked. So, yeah, so let's go and check out um, the not planet Pluto, the largest of our dwarf planets. It's way out there. And you may notice every now and then, I'm going to try and move a bit away from Enceladus and Saturn. So in OpenSpace, I have this control that kind of toggles the orbits of the planets on and off. All right, so we have these big, beautiful spirals of the planets, but along with those, there's also a tiny little streak that I always ignore. I just pretend that it's not there, but today I'm gonna call attention to it. So if you see more of these, you might notice that in some of the views. So yeah, that's Pluto there. So we're gonna go pop on over to to Pluto, which does have some serious ices happening. So go ahead and move in there. So again, Pluto, not a planet. It was reclassified. I don't want to say demoted. I don't want to say kicked out. It's so negative. It's a classification. Like we like to put things in boxes. We decided to move it from one box to another box, and we kind of like made a whole box just for Pluto and friends. So dwarf planet, it's massive enough to have pulled itself into a spherical shape. It orbits the sun and not another planet. Well, mostly. Um, but it hasn't quite, quote unquote, cleared its orbit. So it's out here in a region of space where there are a lot of a lot of other worlds that are of comparable size. So just looking at this, you actually see like a little rotation line, kind of an orbit line for Pluto itself. So right now what I'm actually focused on is the center of mass for the Pluto-Charon system. So its largest moon is actually a large percentage of Pluto's size. So it's almost like a double dwarf planet system. So you can see Pluto actually does make a little bit of a wobble there as it moves around, as Pluto and Charon move around a common center of mass. So actually, if I just kind of look at this was something I was trying to show a few weeks ago, or maybe it was something different. It was showing how the Earth is moving. The Earth-Moon system also have a barycenter. Let me just turn on time so we can kind of see how they move around each other. So the Earth-Moon system also have this barycenter, this center of mass that they orbit about. So the barycenter would be in here, but in the case of the Earth-Moon system, the barycenter is actually inside of the Earth. So the moon really does go around the Earth because the barycenter is inside the Earth. But we are here to see ices. So it's nice that Pluto has all these fabulous moons. And we have images of those from the New Horizons mission that visited, 2015. It went zipping by. So if you're as old as me, way back when, Pluto used to be like, 4 pixels. And that was Pluto. It was 4 pixels. And then the Hubble Space Telescope came along, and then Pluto became a golf ball. With these super high resolution, new powered telescope, and that was all the rage. And then New Horizons came along, and it's like, oh, Pluto has a heart. Isn't that cute? So pretty amazing just to see technology progressing and giving us more detailed images and more information about these amazing worlds in our solar system. So the famous heart, that's kind of the Tomball region. named after Clyde Tombaugh, who was the American that discovered Pluto. He kind of knew where to look. We knew that there was something out there kind of tugging on Neptune gravitationally. And so we wound up, looking in a region. It's a little bit off the ecliptic, a little bit off the line that the planets lie along. So I think that's why it took a little bit longer for them to find it. But he spent just night after night looking at these plates, kind of blinking them back and forth, looking for the dot that moved. And eventually he found this dot, all 4 pixels of it, that moved. It wasn't a pixel in the 30s, but just, yeah, 1930s version of a pixel. So interestingly, this whiter region, the Tomball region, the heart, um, that's more reflective. So it looks more like the surface of Enceladus, but there's not as much ice there. The iciest parts are actually these darker regions. So this is the eastern part of the Cthulhu region, um, on Pluto, and very heavily covered in water ice. So actually, I checked the maps for water ice, I believe, and so maybe there are other ices that I'm not aware of. But as far as water ice goes, there's a there's loads and loads of water all over our solar system, even way out in Pluto. So the most of the water, if you're going to go to Pluto, take a little bit of it, not so much a field trip. That's like a lifetime commitment there. All the way out to Pluto, you're gonna want to camp around here to get your water ice. Um, so that darker Cthulhu region. But all over here, there's a lot of ice. There's a the Viking region, a little bit lighter in color. Above that, also has a lot of water, as well. But out here, again, just water can be super, super hard. So it's not going to be liquid. We're way out beyond what we might call the frost line, where these ices, the materials that I listed earlier, it's not just water, but ammonia, methane, they're solids. On Titan, the moon of Saturn that the Cassini-Huygens probe landed on, their water is like boulder hard. It's like you have boulders of solid ice, and then you have liquid methane slush. So out here, methane wouldn't be slush anymore. It would definitely be frozen solid out there on Pluto. So beautiful maps of Pluto, and if you download OpenSpace, you can explore Pluto in all of its glory in all your spare time. But just a nice kind of cool trip if you want to get away from the heat. We're way out here, outer solar system, pretty chill, just chillaxing with Pluto and its dwarf planet moons. Beyond that, again, we have more asteroid-like objects. We have the comets that are super, super cool, all year round. So that's our little tour for this week. I'm just going to aim us back homeward. And thank you. Thanks for watching. Again, we've been using, I'm just going to put this back up. We've been using OpenSpace, OpenSpace software here, as well as, so I target Earth. Sorry, I'm having issues. Using OpenSpace software, and also the Stellarium, which you can download at their respective websites. Again, I'm Irene Pease with the Amateur Astronomers Association of New York, and I encourage you to check out the other fun things that we have on our YouTube channel. We have a very active astrophotography group, and one of the people who leads that did a really cool talk on some of the photography that he's done. So check out our other stuff. Feel free to subscribe. Follow us on social media. We're AAADOTORG. And be safe out there. We'll see you next week.